let's start the chapter. Our first topic is about chemical reaction, a process where reactants and are transformed into products. So chemical reaction is a process where reactants are transferred into products. Let you can take an example of carbon and oxygen. Carbon and oxygens are the reactants and it transforms into a product carbon dioxide. Now come to the characteristics of chemical reaction. Change in state, change in color, evolution of gas, change in temperature, formation of precipitate. So what are the characteristics of chemical reactions? Characteristics are that if the chemical reaction takes place, so there has been the change in the state, solid, liquid or gases, and may there has been the change in the color, evolution of the gas like hydrogen gas, and there may be the changes in the temperature and the formation of the precipitate. And precipitate means to say that anything which doesn't dissolve or doesn't soluble in water. Chemical equation, it is a representation of a chemical reaction using symbols and formulas. Example, H2 and O2 equals to H2O. So there is in this equation there is the only using of the symbols and the formulas of like hydrogen plus oxygen refers to the water, and here in this equation there is the symbols and the formulas. Next one is the balancing chemical equation. It follows the law of conservation of mass, and law of conservation of mass said that the total mass in reactant and in product side must be equal. And just example, if in the reactant side there is the one carbon atom, so in product side also there is the one carbon atom, and if there is two carbon atom in reactant side, so it must to be two carbon atom in product side. So law of conservation of mass said that the total mass in the reactants and in the product side should to be equal. Step to balance, write the unbalanced equation and count the number of atoms for each element. First you need to write the unbalanced equation, and after that you need to count the number of atoms. That in the reactant side how much atoms are there in the element, and in product side how much there. And after that, after counting that number, you need to adjust the coefficient to balance the atoms and ensure coefficients are in the simplest ratio. For example, there is the unbalanced equation Fe plus H2O, formation of the Fe3O4 plus H2O, or you can say that iron plus water, so iron oxide and hydrogen. So you can see that in the reactant side the number of atoms in iron element is 1, but in the product side there is 3, so you need to balance it both. So after when we balance here, iron is also being 3 and in product side also it being already 3, and in the reactant side it being 3. When we put the coefficient 3 before iron, and if we just look in the questions unbalanced equation, hydrogen is the atom of the hydrogen is 2 in the reactant side, and in the product side also 2, and in reactant side oxygen is 1, and in product side oxygen is 4. It means that the number of the atom of the oxygen element is not balanced and you need to balance it. So we need to put 4 uh, before the H2O, so that the oxygen being 4 in the reactant side and as well as the product side. Because of this, the hydrogen being 4 into 2 8 in reactant side, and you need to do the 8 hydrogen atom in product side, so we put 4 before hydrogen in product side. Now you can check that the iron is 3, hydrogen is 8, hydrogen is 8, and the oxygen is 4, and in product side also oxygen is 4. It means it being balanced. Now the type of chemical reaction. So first one is the combination reaction. Combination reactions refers that if two or more reactants combine to form a single product. Example, calcium oxide plus water. So there is a formation of calcium hydroxide. Or you can take an example of hydrogen plus oxygen. So there is the formation of water. Decomposition reaction, if a compound requires energy to split or break, so it's be a decomposition reaction. A single reactant breaks down into two or more products. For example, here is the example of lead nitrate given. So um, it breaks into lead oxide, nitrogen oxide, and oxygen. And you can take this simple example also, like carbon dioxide and um, in the reactant side, and when we pass the heat, then these carbon dioxide split into two parts, carbon and oxygen. And if we pass the energy, and let's take water in the reactant side and pass the energy, so this water is split into two pieces, hydrogen and oxygen. So it's also a decomposition reaction. And displacement, if one element displaces the another, so it's called a displacement reaction. Example, zinc and copper sulfate. So zinc displaces the copper and takes the place of copper, and copper being separate. So zinc is more reactive than copper, and so zinc displaces the copper. Double displacement, there is exchange of ions between two compounds like sodium sulfate and barium chloride. So in these two compounds there is exchange of ions. So the in result side there is the formation of barium sulfate and sodium chloride. Double displacement reaction, exchange of ions between two compounds. And as we looked at sodium sulfate, barium chloride, so there is a formation of barium sulfate and sodium chloride. Now come to the next topic, oxidation and the reduction. It's also called redox reaction. So you can define the redox reaction as the reaction in which oxidation and reductions both takes place at the same time. Oxidation refers to the gain of the oxygen and or loss of the electron. Reduction refers to the loss of the oxygen or gain of electrons.